Hello students, in this video I am going to explain about the arithmetic operation of binary numbers. It includes addition, subtraction, multiplication and division, including the fractional numbers. Before learning the binary arithmetic, you should aware of the sequence of binary numbers. This table illustrates the sequence of decimal numbers and its binary equivalent. We know already when one is added with another one, we can get 2. But in binary number system, when one is added with another one, we can get 1 0. So you should aware of the next sequences of binary numbers. Binary addition is the addition of any one of the two numbers 0 or 1. When we add 0 plus 0, we can get 0. 0 plus 1, 1. 1 plus 0, 1. We know that already after the value 1, the next number is 10. So 1 plus 1 is 10. Write the 0 here and carry the 1 into the left hand side of the bit. So this number is called carry. This is the meaning for the fourth rule. Let's see the example in the addition operation. The first number is called oggend, the second number is called addend. We have to apply this simple addition rule here. So 0 plus 0, 0, 1 plus 1, 10, carry is 1, 1 plus 0 plus 0, 1, 1 plus 0, 1. You can cross-check the result by converting these binary numbers into equivalent decimal value. So the first number is 10, second number is 2, the result is 12. 1100 is the equivalent binary number of 12. The another important point is, even though we are adding two numbers, in some cases we are adding three numbers due to the inclusion of carry. So we can use the 3-input addition truth table. The possible inputs are illustrated with the corresponding result and carry. So when we add the first two numbers, assume that the default value is 0. So 0 plus 0 plus 0, so you can use this row. The sum is 0, carry is 0. That carry can be taken into the next left hand side bit. So 0, 1, 1. So 0, 1, 1. You can get the result is 0 and the carry is 1. So result is 0, carry is 1. 1, 0, 1, 0, result is 1, carry is 0, result is 1, carry is 0, 0, 1, 0, 0, 1, 0, the result is 1, carry is 0. So you can also use this truth table to achieve the simple addition operation. There are some other examples. You try it yourself and cross-check your answer. The next part is fractional addition. The fractional numbers contains two parts. One is whole number, second one is fractional number separated by the dot. 10.75 is the decimal equivalent of this number. 2.25 is the decimal equivalent of the second number. I am finding these two numbers only because cross-checking purpose. You can directly do the addition operation without finding these two numbers. So 1 plus 1, 10, carry is 1. 1 plus 1 plus 0, 10, carry is 1. Add the dot operator. Then 1 plus 0 plus 0, 1. 1 plus 1, 10, carry is 1. 1 plus 0 plus 0, 1. Then 1 plus 0, 1. You can cross-check the result by means of decimal number. So this is 13.00. Addition operation is over. Let's move to the subtraction process. Binary subtraction is the process of subtracting two numbers. The two numbers are zeros and 1. We can achieve the subtraction by these three ways. The first number is always greater than the second number. When this condition is satisfied, you can apply the simple subtraction rules. Otherwise, you can go to the 1's complement method or 2's complement method. First, we see the simple subtraction method. So this is a simple subtraction rule. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. These three rules are simple. But 0 minus 1, the answer is 1. Usually, 1 is not subtracted from 0. We need to borrow from the left hand side of this number and continue the subtraction operation. If there is no number in left hand side, we put the difference between these two numbers and mention this is the negative number. So, the 0 minus 1, the result is always 1. But in background process, we can borrow the value 1. So this is the simple subtraction rule we have to follow. Let's see the subtraction process through some examples. Here I want to subtract 2 from 8. The first number is minuend, the second number is subtrahend. This is the rule to be applied on the entire subtraction process. 0 minus 0, 0. 1 cannot subtracted from 0. So I can try to borrow from the left hand side number. This is also 0. So I can do the borrow from the left hand side of this number. After borrowing the number 1, it becomes 0 and this value becomes 1, 0. And do the borrow process again. This value becomes 1. This value becomes 10. Now I can do the subtraction process. 10 minus 1, 1. This value becomes 1. 1 minus 0, 1. This value becomes 0. 0 minus 0, 0. So this is the actual result of this subtraction process. Let's see the another example. Here I want to subtract 38 from 52. 0 minus 0, 0. 0 minus 1 cannot happen. So I can borrow from here. So this value becomes 0. This value becomes 10. 10 minus 1, 1. 0 minus 1 cannot happen. So I can try to borrow here. This value again 0. So first I can borrow from here. So this value becomes 0. This becomes 10. Then again do the borrow operation. So this value becomes 1. This value becomes 10. 10 minus 1, 1. 1 minus 0, 1. 0 minus 0, 0. And 1 minus 1, 0. So 1110 is the answer. You can cross check this value from the equivalent decimal number. 52 minus 38 you can get 14. So decimal equivalent of 1110 is 14. Let's we move to the subtraction using the ones complement method. This method contains 4 rules. First you have to find the ones complement for the second number, that is subtrahend. Then add the result to the first number, that is minuend. If the result having carry, you can add the value to the result. If the result having no carry, you can find the ones complement for the result. Let's check the ones complement method through some examples. In this example, I want to subtract 10 from 1000. So the first rule is find the ones complement for the second number. So 0 can be written as 1, 1 can be written as 0. So the ones complement result is 1101. I can write the first number, then I want to do the addition operation. 0 plus 1, 1, 0 plus 0, 0, 0 plus 1, 1, 1 plus 1, 10, carry is 1. If the result is having carry, so I can add the carry to the result. Then I can get 0110. So this is the result of 1000 minus 10. You can cross check this answer. 1000 is 8, 10 is 2, 8 minus 2 you can get 6. In the second case, I can take the first number is the smaller number, that is 10. Second number is the big number, that is 8. Let's check what happens if the ones complement method rules are applied. So first I want to find the ones complement for the second number. So the result is 0111. Then add this result to the first number. I can get this answer. It does not contain any carry. So the rule is if there is no carry, you can find the ones complement for the result. So I want to find the ones complement for this result. The value is 0110. But this is the negative number. This is the next example. You can try it yourself and cross check the answer. Let's move to the two's complement subtraction process. The first rule is you have to find the two's complement number of subtrahend, that is second number. The result can be added with the first number. If the result has carry, you can ignore it, that is the positive number. If there is no carry, you can find the two's complement of the result, then the result is negative number. You just compare these two complement methods. In first complement method, you can find the first complement of the second number. Here also, you can find the two's complement for the second number. In the second step, you can add the first complement with the first number. Here also, you can add the result with the first number. In third rule, if there is a carry, you can add the carry with the result. But in this case, if there is a carry, you just ignore it. In the fourth rule, if there is no carry, you can find the ones complement for the result. Here also, If there is no carry, you have to find the 2's complement of the result. So you just compare these rules and remember the process. So let's apply the 2's complement method in some examples. Here I want to subtract 10 from 1000. So the first step is I want to find the 2's complement of the second number. So first I find the ones complement method. So 1101. I want to add 1. So 1 plus 1, 10. Carry is 1. 1 plus 0, 1. 1, 1. So the 2's complement for 0010 is 1110. So I can write 1110. I added with the first number. I can get this result. The result contains carry. If there is a carry, you can ignore it. The result is a positive number. So I ignore this carry. The result is 110. So if you want to subtract 8 from 2, you can get 6. Let's apply the same 2's complement method when the first number is smaller than the second number. So the first step is find the 2's complement for this number. So the 2's complement for 1000 is 1000. First you have to find the 1's complement. So 011 add with 1 you can get 1000. I add this value to the first number. After adding these two numbers I can get this value. Here there is no carry. If there is no carry, it is a negative number. We need to take the 2's complement for the result. So first write the 1's complement number. So 0101 added with 1, you can get 0110. So this is the result for 10 minus 1000. But this is the negative number. I hope you understand to perform the binary subtraction by using these three methods. Let's see the binary subtraction involving the fractional numbers. In this example, I am going to subtract 11.01 from 101.11. These are all the decimal equivalent for these two numbers. This is for cross-checking purpose only. You can do the subtraction operation directly from these two numbers. 1 minus 1, 0. 1 minus 0, 1. You can add the dot. 1 minus 1, 0. 1 cannot subtract it from 0. So I can borrow from here. So this value becomes 0 and this value becomes 1, 0. So 1, 0 minus 1, you can get 1. 0 minus 0, you can get 0. So this is the result. 10.10 is the result. The equivalent decimal value is 2.5. You can cross-check this value. Let's move to the example 2. I can take this value because we can do the borrow operation from whole part to the fractional part. 1 minus 1, 0. 0 minus 1 cannot happen. So I can borrow 1 from the left hand side. So this value becomes 0. So I can explain in the another place. This is simple one, but you need some understanding. So I can do this in another place. So 1 minus 1, 0. 1 cannot subtract it from 0. So I can borrow from the left hand side. This value becomes 0. This value becomes 1, 0. So 1, 0 minus 1, you can get 1. Add the dot part. 1 cannot subtract it from 0. So I can try to borrow from the left hand side. This value also 0. So I can borrow again. So this value becomes 0. This value becomes 1. I can do borrow operation again. So this value becomes 1. This value becomes 10. So 10 minus 1, 1. 1 minus 1, 0. 0 minus 0, 0. So this is what happened here. So 1.1 is the answer. The equivalent decimal value is 1.5. You can cross-check this value. Let's move the binary fractional numbers by using 1's complement method. The second number can be converted into 1's complement number. So I can write the second number here and converted all zeros into 1, 1 into 0. So the 1's complement number is 100.10. I can add this result with the first number. So 101, 1110, carry is 1. 1 plus 1 plus 0, 10, carry is 1. 1 plus 0 plus 0, 1. 1 plus 1, 10, carry is 1. If there is a carry, you can add the carry with the result. So after adding, you can get this value. So 10.1 is the result. If you convert it into the decimal number, you can get 2.5. You can cross-check this result with the normal decimal subtraction. In the next example, I want to do the subtraction process with the same numbers but using the 2's complement method. So I can find the 2's complement for the second number. First I write the 1's complement for this number, then add with 1, I can get the 2's complement number. Then this result can be added with the first number. 1 plus 1 10, carry is 1. 1 plus 1 plus 1 1, carry is 1. 1 plus 1 10, carry is 1. 1 plus 0 plus 0 1. 1 plus 1 10, carry is 1. If there is a carry in the 2's complement method, you just ignore it. So I can take the result as it is. The value is 2.5. In the last example, I am going to subtract the bigger number from the smaller number. First I write the 1's complement number, then add with 1, I can get the 2's complement for the second number. So I can write the second number here and write the first number here. Then I do the addition operation. 1 plus 1, 10, carry is 1. 1 plus 0 plus 0, 1. Add the dot operator. 1 plus 0 is 1. 1 plus 1 is 10, carry is 1. 1 plus 0 plus 0 is 1. Here there is no carry is occur. So in a 2's complement method, if there is no carry in the result, you can find the 2's complement for this result. So here I rewrite the result and write the first complement number, add with 1 and get the 2's complement number. So the 2's complement number is the final result. So up to this, binary subtraction is over, including fractional numbers. Let's move to the multiplication process. In a multiplication, the first number is called multiplicand, the second number is called multiplier. We have to apply the simple rules like addition and subtraction. 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So all these four rules are simple only. We can apply this rule for the multiplication process. So first I take the LSB of multiplier. I can multiply this value to the multiplicand. So I can get 1010 and the next bit is 0. I multiplied the 0 with this multiplicand. So I can get all the values are 0. And the third value is 1. So I can get 1010. So in this process, we need not to multiply these two numbers. Actually, we apply the simple rule. If the multiplier bit is 1, then you can write the multiplicand as it is. If the multiplier bit is 0, you can put the zeros. So instead of actual multiplication, you can either write the multiplicand value or 0 in the partial addition process. So the multiplication of binary numbers is very simple compared to binary subtraction process. Then we have to add these three numbers. You can get this result. Let's move to the multiplication of fractional numbers. For the fractional multiplication, first you eliminate the fractional part by shifting this dot. So I can move this dot into one position to become this number is whole number. In the second case also, I can move this dot into one position so I can get the full number. The important point is 0 can be negligible after the dot. So both the numbers are whole number only. Now you can do the normal binary operation. You can get the result like this. After that, you can shift the 2 bit in the result. So this is the result for this fractional multiplication. In the second example, the first number need 2 position shift. So I can get this value. In the second number, I need just 1 bit to shift to get the whole number. Just ignore the 0 after this dot part. So totally 3 bits needed to get the whole number for multiplier as well as multiplicand. Then do the normal multiplication operation, you can get this result. Then shift the dot is into 3 position. So this is the final result for multiplication of these two fractional numbers. Then the last arithmetic operation is division. Here the first number is called dividend and the second number is called divisor. You can do the division operation as we do in the decimal number. So I can put 1 into 101, 101. Then I do the simple subtraction process. 101 minus 101, I can get 0. Then I bring the 0 here. 101 cannot fit this number, so I can 0 in the quotient part. So this is the result. Quotient is 10 and remainder is 0. You can cross check this value by comparing the equivalent decimal number. It is 10, it is 5. If you divide the 10 by 5, you can get the result 2 and the remainder is 0. You can do this problem yourself and cross-check your answer. Let's move to the division operation by fractional numbers. In the fractional division process, there are three cases. In first case, the divisor is the full number, dividend is the fractional number. In the second case, divisor is the fractional number, dividend is the full number. In the third case, both the numbers are fractional numbers. The simple technique is we have to eliminate the fractional part. In the first case, I want to shift this dot into two position so that I can add two zeros here. So 10.11 becomes 1011.0. 10 becomes 1000.0. Then we have to do the normal division operation. So you can get the result like this. So 1 is the quotient, 1 is the remainder. We need not change anything because we do the modification in both numerator and denominator. So this is the final result for this division operation. In the second case, the denominator having the fractional part. I want to eliminate it. So I can shift this dot into the right hand side. So I can add 0 from the numerator. Now these two values are same in the previous one. Now I want to do the normal division operation. So you can get this result. So this is the answer for division of these two numbers. In the third case, both the numbers are having the fractional part. First check whether the numerator or denominator needed to shift the maximum shifting position. Here the numerator need to shift two positions. So I want to shift the dot into two position here. So I want to shift the two position in the denominator also. So first I shift the dot here. In the second shifting, I can add the 0 here. 10.11 becomes 1011.0. 10.1 becomes 1010.0. So these two values are same only. Now I can do the normal division operation. I can get the result like this. So this is the result for fractional numbers division. I hope you learn about how to do the binary addition, subtraction, multiplication and division including the fractional numbers. If you want to any clarification, you can raise your queries through the comments. Thank you.